So this problem is asking us how much energy is required to completely vaporize 200 grams of 25 degrees Celsius liquid water. So first what you need to do is draw a phase diagram, which is drawn right here. If you don't know how to draw a phase diagram, you should go and review that before watching this video. So we have we're starting out at 25 degrees Celsius. So that is it. When water is at 25 degrees Celsius, it is a liquid. So it would be in between C and E. So since 0 is the melting point, which would be point C, and the boiling point is 100 degrees, which is point E, D falls right about 1/4 of the way up because it's 25 degrees Celsius. So D is 25 degrees Celsius, and that's where we're starting. Okay, so D is our start point. Now the problem asks us the energy required to completely vaporize it. So vaporization occurs at point F, where the liquid becomes a gas. So we end at point F. So we're going from point D to point E to point F. So this is point D to point E is a temperature change, and point E to F is a phase change. So there's going to be one temperature change and one phase change. So we know that going from point D to point E is a temperature change because the temperature increases. So for point D to point E, we're going to use the temperature change equation. So, oh wait, give me a minute. So Q of line segment DE equals the mass, so 200 grams times the specific heat. So since we're in the liquid stage, right here from point D to point E, we're going to use the specific heat of liquid, which is right here. This will be given to you on an exam. You don't have to memorize this. So the specific heat of water at the liquid stage is 4.184 joules per gram degrees Celsius. Now we multiply that by the change in temperature. So point D to point E. So we started at 25 degrees and now we're at 100. So 100 minus 25 is 75 degrees Celsius. So once you multiply this, you're going to get 62. Wait, give me 1 minute. 200 times 1 point times 75. You're going to get 62,760 joules. And then we're going to convert that to kilojoules. So 62.760 kilojoules from point D to point E. So that was the temperature change. Now, so since we have point D to point E figured out, we have to go from point E to point F. So, does the temperature change from point E to point F? No. But does the phase change? Yes. It's going from a liquid to a gas. So, we're going to use the phase change equation. So, Q of line segment EF is equal to the moles. So, how do we get moles? You take the amount given to you and divide that by the molar mass. The molar mass is water. The molar mass of water is 18 grams a mole, and that leaves you with about 11.1 moles of water. So now we multiply that by the entropy of H. So the entropy of H can be two things. It can be the heat of fusion, or it could be the heat of vaporization. So because we're going from a liquid to a gas, it's the heat of vaporization. If we were going from a solid to a liquid, it would be the heat of fusion. But since we're going from a liquid to a gas, it's heat of vaporization. Think of it like gas and vapor. They're similar, right? So that's why we use the heat of vaporization since we're going from liquid to gas. So we take the value for heat of vaporization, 40.7 kilojoules a mole, and then we multiply. So moles and moles cancel out, so 11.1 times 40.7 equals 451.77 kilojoules. So next, the last step is to add the two values up. So we add this and this together. So plus 62.760. And as a final answer, you get 514.53. So, kilojoules. So your answer is 514.53 kilojoules is required to completely vaporize 200 grams of 25 degree Celsius liquid water. And that's your answer.